So thank you very much. Hello, everybody. So we will move to the impacted peoples of climate change. I will speak about low and mid-trophic levels reanalysis in the European Copernicus Marine Service. And I will give you an overview of the state of the current product, and especially the model that we use to produce this kind of data, and what we can do with that. So I will first describe quickly the model CPODIM that we use to do the reanalysis. How we validate the key variables of this model. What are the applications of what we produce for science and society, and what's new, what's going on this model also, because we continually try to improve the estimation. So what are the low and mid-trophic levels of ocean? We have a large diversity of species in the ocean, and we are focusing on the zooplankton and microplankton that constitute the low for zooplankton and mid-trophic level of the food web that start with phytoplankton and ends with top predator like tuna or human. Zooplankton means animals that are drifting, so they are transporting by the current. They have no capability to swim. And the microplankton means that there are animals that are able to swim, but they have no autonomous velocity like predators, for instance. So they are transported by the current, but have a diffusive component. So the model that we use for computing the distribution of density of this population is CPODIM. This model is based on a set of advection diffusion reaction equations, which is a bit smart for this kind of studies, because in marine ecology it's not very used. And so the idea is to take this kind of equation, and the density of population is transported by the current, okay, here. And there is also the diffusion equation parameter. The source term is given by the net primary productivity, and also so the population is discretized in age, and we differentiate the two age stages of this population by a production life stage that are larvae and juveniles, and a second age stage, which are composed of adults. And in the equation of adults, the source of energy of animals is given by the recruited production. All these parameters in the equation, like for instance for the mortality, are given by studies that we can find in some papers. For the zooplankton, we consider that is live in the first layer of the ocean, and we decompose the ocean in 3 layers that depends on the euphotic depth. We have 3 pelagic layers. So zooplankton is only inhabits the first layers, but for microplankton we consider 6 functional groups of species that all taxa are grouped in functional groups, and we have groups that stay in each layer, and as they have a diel vertical migration behavior, we also consider groups that migrate from one layer to another layer. So how we validate this model? First, we need to validate the pelagic layer bottom depth by taking acoustic transect, and in acoustic transect you can see very well the vertical migration of microneutron during day-night alternation. And so we use machine learning algorithm to detect the bottom depth of each layers, and then we can compare with our model that is based on optic depth. For zooplankton, we use the very large dataset Copepod. At the moment, we don't use pointwise comparison because it's quite difficult, because we have not the same space and time resolution. So we compared with the distribution. So we can see that in our model we have some problems, still some problems. For microneutron, it's very much more complicated because we have very poor and less data. We have data at a global scale, so we can estimate the total biomass, but we have also some sparse observation at regional scale, but they are very, there are not a lot. So if you want more details about this, there is a document that resume all this validation. So what we can do with this kind of model? The first, we were involved in two important European projects, Mission Atlantic, whose aim was to study the impact of climate change on distribution of biomass of microneutron. And you can see in that for two models and two scenarios, we conclude that the biomass will decrease. There are the area in red, and a few area where the biomass is expected to increase. And the other one is the MISO project. The idea was to study the impact of harvest on two species of microneutron, which are Morolicus and Bentosema. And you can see in this figure. So in yellow you have the original without the original time series without harvesting. The blue one is for 5% harvesting, and the brown one is for 25% harvesting. We also have a colleague that works on Antarctic ecosystem. He worked about the Antarctic krill, for instance. So it was by taking into account the microneutron as a predator for eggs, it was able to determine spawning habitat of krill Antarctic krill, and also it was able to estimate the duration of high quality spawning habitat for this species. Another example in Antarctic is the predator foraging success of macaroni penguins. So it was able to locate the prey emergent and theoretically expected foraging areas. So it was done by the use of the reanalysis of microneutron. So what's new now in the model? So first, the first version of the model was using a regular grid and it was not very good especially in high latitude. So this year we changed the grid, and we use an overset grid that is called the yin-yang overset grid, which was proposed by Kageyama and Sato in 2004. And the idea is to use the same grid that is the same. The idea is to use one algebraic grid, which is an extraction of the global latitude longitude normal grid, and to use symmetric change of coordinate system to get two overset grids. And so you have here the, for instance, an evaluation of micronecton on the first grid and the second grid here. So since 4 or 5 years, we propose a reanalysis of zooplankton and micronecton product for the Copernicus Marine Service, and it helps us to improve our model, because the quality of the product in Copernicus Marine Service is very high, so it's very difficult for us to to go, but it's a very good point for us, because we improve a lot our model and the quality of what we propose. So you can get 24, 25 years daily 1/12 degree global estimate of zooplankton and 6 group of micronecton in the catalogue. And now what we plan to do is to ameliorate our model, the numerical scheme, for instance, also using regional products for net primary productivity, which is at the basis of the energy. We plan also to new estimation of pelagic layer depth, which has a very high impact on the forcing terms that we use to transport the population. And we need to improve the parametrization, and for that we need data, and especially for micronecton. So I finished. Thank you. This is people I'm working at the moment on the model, and some references. Thank you.